Hello everyone, welcome back to the new video. So in this video I am going to derive the Nernst equation for a single electrode potential value. Myself Dr. Kailash Chadchan, Assistant Professor in the Department of Chemistry, BLDE Associations, College of Engineering and Technology, Vijayapur, Karnataka, India. So Nernst equation, it gives the relation between the electrode potential value and the concentration of metal ions surrounding that electrode surface. You can see here so assume that a metal, or for instance an electrode, is in contact with its ions. So this electrode will be having its own electropotential value, which is surrounded by its own ions. So Nernst equation gives the relation between the electrode potential value of this electrode and the metal ion concentration surrounding that electrode surface. So now let us derive the Nernst equation for a single electrode potential. So when a metal is in contact with a solution of its own ions, there exists an equilibrium. That equilibrium reaction is Mn plus n number of electrons gives M. So whenever a metal is in contact with its own ions, there exists an equilibrium around the surface. So the equilibrium reaction can be written as Mn plus n number of electrons gives M. So the equilibrium constant for this particular equilibrium reaction can be written as Km, concentration of metal ions. So assume that this is equation number 1. Now, so whenever there is a work done on the electrode surface, it tends to decrease the free energy. That is, there is decrease in the free energy whenever a work is done on the electrode surface. And we know that the maximum work done is given by NFE, where N is the number of electrons, F is Faraday's constant, and E is energy or potential applied. So therefore we can write here as minus delta G is equals to NFE. Similarly, for standard conditions, we can write minus delta G naught is equals to NF E naught, where G naught is the standard free energy change and E naught is the standard electrode potential value of the electrode. So we shall mention this as equation number 2 and this as equation number 3. Now we know that the relation between the change in free energy and the equilibrium constant is delta G equal to delta G naught plus RT ln K. This is the relation between the change in free energy and that of equilibrium constant. So mention this as equation number 4. Now substitute all the values from equation number 1, 2 and 3 in the equation number 4. So delta G is nothing but minus NFE. Delta G naught is nothing but minus NF E naught. We shall keep RT as it is, ln as it is, and K. What is the value of K? So K here is the concentration of M bar, concentration of Mn plus. Now so to further simplify this equation, so we just mention it as minus NFE is equals to minus NFE naught plus RT ln concentration of M minus RT ln concentration of Mn plus. I will write it like this. So this is nothing but log A by B is equals to log A minus log B. Now divide the whole equation by minus NF to further simplify. So what we shall do is we shall divide the whole equation by minus NF. So what it becomes, minus NFE divided by minus NF is equals to minus NFE naught by minus NF plus RT ln concentration of M by minus NF minus of RT ln concentration of Mn plus divided by minus NF. So when we divide it by minus NF for the whole equation, so what we ultimately get is E is equals to E naught plus RT ln concentration of Mn plus divided by NF. So here what actually has happened is this at standard conditions the concentration of metal will be taken as M1. So therefore this entire equation will become 0 because ln of 1 is 0. So therefore we'll ultimately get this as E is equals to E naught plus RT ln concentration of Mn plus bar concentration of NF. Now to further simplify this, we know the values of R, which is equal to 8.314 joules per Kelvin per mole. T, standard conditions means 298 Kelvin. And F is Faraday's constant whose value is 96,500 coulomb per mole. And we know that ln is equals to 2.303 log. So when you substitute all these values, so we will get E is equals to E naught plus 8.314 multiplied by 298 multiplied by 2.303 log. So I just write it here, Mn plus the whole equation is divided by N into 96,500. So when you substitute all these values and when you multiply it, so we'll get it as E is equals to E naught plus 0.0591 by N log of concentration of Mn plus. So this is what the Nernst equation for a single electrode potential is. Okay, so here, so this electrode potential value of an electrode, it completely depends on the concentration of metal ions surrounding that electrode surface. Okay, so I hope you have understood this derivation of Nernst equation for a single electrode potential. Thank you.